Hi everyone, welcome to Codianto. In this video, we will explore the building blocks of class structure in Java. Why do we use packages in Java? Access modifiers, class field and method declarations, difference between static, final, and instance fields, constructors, default constructors, and overloading, difference between overloading and overriding. As Java application grew in size, managing classes became harder. That's why we use packages to organize related code logically, like folders on your computer. Example, we can collect car classes in a vehicle package. For calculation and API calls, we can create a services package. For the utility classes, we can create utility package. In this project, we also created packages like Video 1 and Video 2. Inside Video 2, topics are divided into access modifier and declaring packages. Packages also affect access level, which we will discuss next. Access modifiers define who can access your classes and class members. Public is for accessible from anywhere. Protected is for same package and subclasses. Default is for only within the same package. And private is for only within the same class. Let's use our IntelliJ example where we define the car class in package 1. Into our car class, we define Ford field with different access level. Model is private, speed is protected, color default, and year is public. And tested access from package 1 and package 2 using test package 1 and test package 2 classes. Into test package 1, we can access speed, color, and year. When we try to access model, we cannot access it because model is private. Only access in the same class. Let's check test package 2. We can access year is public, accessible from anywhere. But when we try to access other fields, model, speed, and color cannot be accessible from other package. Okay, let's talk about class declaration syntax. This is our class, electric car. Public is the access modifier. And electric car extends from car. Car is superclass. And electric car implements two different interfaces, trackable and chargeable. This is really important and it can be asked in the interview. A class can extend only one superclass but implement multiple interfaces at once. Java supports single class inheritance and multiple interfaces implementation. Let's check fields declarations, car. Fields has access modifier, specifier like static, final, and a type, field name, and initial value. Field stores the state of an object. They are declared inside the class but outside any method. And here there are specifiers, final and static. Final is for define a value, constant and cannot be changed. Here is really important, final cannot be changed after it's initialized. If we try to change its value, like here, we will have an error. Code will not be compiled. We cannot define a setter for a final, like here. We will have same compiler error. That means final cannot be initialized, no setter method, but a getter is only. And static is another specifier, is for shared across all instances of the class. For example, we have two counters here. One of them is static and the other is instance count. When we create two car objects, total cars becomes 2, but each object has its own instance count starting from 1 every time. Let's check an example together. We created two car objects, car 1 and car 2. When we check the instance count for car 1 and instance count for car 2, it will be 1 because each object has its own instance count. But when we check total cars for car 1, car 2, total cars should be 2 because it depends on the class, not depends on the object. And as you see here, we can access total car without any initializer. because it's static. Let's run and check the result together. Okay, and here is the result. Instance count for car1 and car2 is 1, and total count for car1 and car2, 2. Why? Because static field belongs to the car itself, not to any specific object. That means all objects share the same total car, while each object has its own copy of instance count. Let's check a method together. And here we have a method, getMaxSpeed. Here is the access modifier, and static is a specifier. And we will have a return type and method name. And here is the parameters. Let's talk about constructors. Here is a car constructor. Constructors are special methods used to initialize parameter. No return type, must have the same name as the class. A constructor is automatically called when an object is created using the new keyword. It sets up initial values and states. Let's put a debug here and call application main method with debug mode. And we are here. When we continue, okay, it's come here. If you don't define any constructor, Java provides a non-argument default constructors. Let's check electric car together. Okay, we have a class electric car here and we have an empty body. We don't define any constructor here, but when we check the electric car class and under classes video 2, declaring electric car here, as you see we have a default a non-argument constructor here. When no args constructor is defined, Java gives us a no-argument constructor automatically. So, because of that, we can create an electric car object with no argument constructor. But if we define a constructor here with an argument, what happens? Let's check object instance in application class. We have a compiler error here. Why? Because once you define your own constructor, the built one is no longer available. To fix that, either use the define constructor or manually create a non-argument one. Let's talk about static methods. Into the car class, I will define a static method and print message. Static methods belongs to the class, like static fields, not to an object, so we can call them directly using the call class name. Let's call the method into the application class with car.print message. Like static fields, we can access the static methods also without an instance. Run the main code and check the result together. This is a static method. Also, the main method is static because the JVM invoke it without creating an object. Okay, let's return to car class definition. Let's create another constructor here. Okay, constructors are methods also. And we have same name methods here with different parameter. Do you know what's named in Java? It's overloading. Same name, different parameters. Useful for constructor or method flexibility. For example, we can define another method instead of constructor with same name with different parameters. Overloading lets us create multiple versions of a method or constructor with different parameters for different use cases. And this is very important to know what is overloading and what is overriding, what is their difference, because generally in the interview, the differences of overloading and overriding is asked. Let's check what is the overriding also. Into our car class, we define another method, start engine. And remember that electric car extends from car class. So, into the electric car, we can override any method declared into car class also to change its behavior. Overloading is same method name with different parameters. Overriding is same methods with same parameters, different behaviors. In this video, we learned what packages are and why they matter, the role of public, private, protected, and default, how to declare class fields and methods, constructors, overloadings vs overriding, difference between static and instance fields, why the main method is static. In the next video, we'll deep dive object-oriented principles. Thank you for watching, friends. See you in the next one.